Hi everyone, this is Dr. Nak and we're going to go over section 2.5, solve linear inequalities. So let's first practice how to say each symbol. So there are 4 kinds of inequalities. So if I write something like this is less than. And then if I put an equal sign on the bottom of it, we call this less than or equal to. Okay, now let's go this way. So in this case, we read it as greater than. And then if I put an equal sign on the bottom, you'll say greater or equal to. Now let's go over how to graph the inequalities, write the solution set in interval notations, and set builder notations. Alright, so let's take a look at the first example. So I'm going to have this open parentheses. If you hear the heavy breathing, that is my dog. There's no creepers on the background, by the way. Alright, so but anyway, so let me just shade this side. Just like this. Okay, now pretend this is your x-axis. And then on this side is negative infinity, positive infinity. Okay, so now how do I translate this in terms of an interval notation? Well, it's going to be open a, comma, and then infinity, open. By the way, negative infinity and infinity side are always open no matter what, because they're not numbers, believe it or not. Alright, now how do you write the set builder notation will be this. We write this as set of all x values such that all the x's are strictly greater than a. So notice that the shaded area, pretend that's all the x values. So notice that all the shaded regions are greater than a. So we say that all the x values must be greater than a. Let's take a look at another one. So instead of the parentheses, I call that open parentheses, but suppose I have the closed bracket, and I'm going to shade the same exact side. And again, this is negative infinity, positive infinity. Okay, so let's go with the interval notation. So the interval notation would be close bracket a, comma, positive infinity. Again, infinity side is always open. In case you're not too familiar with this, if you have an open parentheses, that means that value of a is not included in a solution set. And then if I have a closed bracket with an a, that means that a is included as a part of your solution set. Anyways, let's go with the set builder. So we write it as settable x values such that all the shaded regions, which is x, is going to be greater or equal to a. Now let's look at another case. So I'm going to go towards the other side now. So I'm going to have an open parentheses like this, and I'm going to shade this side. Pretend that this is the x-axis or number line. So this is negative infinity, positive infinity. Alright, so let's go with the interval notation. Where are all the shaded areas? Well, shaded area is going to start from negative infinity. It's going to end at a, but you have an open parentheses, which means that a is not included in the solution set. So we keep it as open. Set builder notation will be settable x values such that all the shaded regions, which is x, is going to be smaller than a, which means that this is going to be strictly less than a. And let's look at the closed bracket situation here. So I'm going to shade this side again, and we got a closed bracket. Okay, so this is negative infinity and positive infinity. Okay, now how do I write this in terms of an interval notation? Well, it's going to go from negative infinity to a, but a is included as a part of the solution set. So I'm just going to put a close bracket. Now the set builder notation is going to be settable x values such that all the shaded regions are less than or equal to a. So that will be the notation for that. Okay, now let's look at the last case. Suppose that whole entire line is being shaded, just like this. Oops. Alright, now how do I write that in interval notation? Open negative infinity to positive infinity, open. And since the whole entire real line's been shaded, we say that the solution set is set of all x values such that x is all real numbers. Or sometimes we write it as big old fat R. Don't worry, we're going to do some examples in a minute. But one thing that you're going to have to know is this. Do you remember that when you're solving an inequality and then if you have to multiply or divide it by a negative number, then your inequality sign must switch. So let me just write that out. So when you multiply or divide by a negative number, the inequality sign switches. So for a little example, suppose I have negative 5x is less than or equal to 10. Now how do you solve for x? Well, you need to divide it by negative 5 on both sides. So now next step is the crucial point. Since you divide it by a negative quantity, right? Next step, your inequality sign switches, just like that. I don't know why I wrote that inequality sign so big, but you get the idea. So here you're going to have x is going to be greater or equal to 10 dividing by negative 5 is negative 2. Alright, so this will be the answer, and that's what I'm talking about by when you multiply or divide it by a negative number, your inequality sign switches. Let's take a look at some examples. So example 1, graph the inequality and write the solution in interval notation and a set builder notations. So every time when I say set notations, what I mean is set builder notations. Okay, so let's take a look at something like this. Let's go nice and easy first, and then we're going to build our ways up. Okay, so let's take a look at x is greater or equal to 4. Alright, now I want to graph this out first. So if I graph this, just jot down the 4. And let's decide where we're going to shade. Now, since this is greater or equal to, every time you see that equal sign, you're guaranteed that you're going to have a closed bracket. Okay, so x is greater or equal to 4. So what we need to do is put a closed bracket, and we're going to be shading this side. Okay, so now let's write this down in terms of an interval notation. The interval notation is going to be close negative 4 to positive infinity, because this side is infinity, this side is negative infinity. Now, how do I write this in a set notation would be set of all x values such that x is greater or equal to 4. Okay, so that's our answer. I should have boxed the graph too, but oh well. Alright, so now let's go with part B. So now let's try to look at something like this. X is less than negative 1/2. Feel free to pause the video and try this on your own. Why am I pausing? Alright, so let me just write down a number line. So this is negative infinity, positive infinity. Let's jot down negative 1/2. Okay, so now let's read this together. All the x values are less than negative 1/2. So in this case, since you don't have the equal sign on the bottom of the less than, you're guaranteed that you're going to have an open parentheses. Now, since all the x values must be less than negative 1/2, what's going to happen is you're going to have an open, and you're going to be shading the left-hand side of the number line. Now, how do I express this in an interval notation? Is this open negative infinity negative 1/2, open. Set notation, settable x values such that x is less than negative 1/2. That's all you gotta do. Alright, so let's increase the level of difficulty a little bit. So let's take a look at part C. Let's go with negative 5 less than x less than 3. So in this case, pretend that all the shaded region, which is all the x values, are sandwiched between negative 5 and 3. So first jot down negative 5 and 3. Okay, now notice that both inequality signs are less than. There's no equal sign. So you for sure, along the number negative 5 and 3, you're going to have an open parentheses. Okay, so since x must be sandwiched between negative 5 and 3, you're going to have to go, all the x values are the shaded region. So you're going to have to shade in between here. How you guys doing on this one? Hopefully you're getting it. Or you can look at it in this way. If I look at this portion only, okay, so this says what? X is greater than negative 5. So x is strictly greater than negative 5 will be, if I have a negative 5 here, you're going to have an open, and then x is greater than, so it's going to go this way. And this is at the same time, x must be, let me just go like this, x must be less than 3. So in that case, if I have a 3 here, x must be strictly less than 3. So we're going to have to go this way. So where do they overlap? Between negative 5 and a 3. That looks like a chicken scratch. All right, but anyways, let me just try to translate this in terms of an interval notation. So the interval notation is going to be open negative 5 comma 3, open. Now the set builder notation is settable x such that x is between negative 5 and a 3. Okay, so here it is. Now let's take a look at another similar problem just to make sure that you're understanding this. So let's look at D. I'm going to keep it very similar. So let's go with negative 5, but in this case I'm going to go less than or equal to x and then less than 3. So let's first jot down the number line. All right, so here's negative 5 and here is 3. Now again, x is sandwiched between negative 5 and a 3, but on the negative 5, you got the less than or equal to. So on negative 5, you better have a closed bracket. Or you can also read this as, I'm going to swap this around, you guys. So x is greater or equal to negative 5. All right, so that means what? You're going to have to shade closed, and then you're going to have to go this way. All right, now if I take a look at this portion. So this is x is less than 3, strictly less than 3. So that means you better have an open parentheses around 3. And then all the x values are less than 3. So you're going to have to shade this way. So where do they overlap? Whoops. So where did they overlap is in between here. The difference is that on the negative 5, you're going to have a closed bracket. On 3, you're going to have an open parentheses. All right, now let's go with the interval notation. It's going to be closed negative 5 and a 3. Set builder notation, settable x such that negative 5 less than or equal to x and then less than 3. There you have it. Okay, we're going to do this problem now. So solve and graph the solution set. Write the solution set in interval notation and a set builder notation. Okay, so let's take a look at part A. We have a minus 5 over 6 is greater than 7 over 10. So first what you want to do is you want to isolate the a. So you need to get rid of that 5 over 6. How do I do that? Add 5 over 6 to both sides. So let me just go plus 5 over 6, and then plus 5 over 6. Now if I do that, then we're going to have a is greater than 7 over 10 plus 5 over 6. So we got little work to do. We need to add those two together. So what we need is we need the least common denominator, LCD. What would be the LCD? Maybe 30. So let me try to rewrite this as 30 on the bottom. So what do we got to do? So right now we have a 10 here. So in order to that to become 30, you need to multiply the bottom by 3. If you're going to do that, multiply by the 3 on the bottom, you better be fair and multiply by 3 on the top. So then here you're going to have 21. Okay, now let's look at 5 over 6. Now, what times 6 is going to give us 30? That's 5. So multiply the top and bottom by 5. So the numerator is going to become 25. So add it, 46 over 30. Now, can I simplify this? Yes, I can. You can divide both by 2, divided by 2, and then divide this number by 2. So if I do that, what are we going to get here? 23 over 15. That's an equal sign, sorry. Okay, so now always reduce your fractions and please make this into a mixed number. So the mixed number will be, how many times is 15 going to go into 23? That's 1. And then what's the remainder? 8. So what do we got? Let's just clean this up a little bit. So therefore, by the way, if I put 3 dots in a triangle like this, this means therefore in a math class. So what do we have? We have therefore we got a is strictly greater than 1 and 8 over 15. Okay, so I think we're ready to express our solution set on the number line, and I think from the number line we should be able to write our solution set in an interval and set notation. So let's do it. So let me just first make the number line. So this is negative infinity, positive infinity. Now jot down 1 and 8 over 15. Alright, now let's translate this together. So notice that instead of an x-axis, we have the a-axis now. Alright, so where should I shade? A is bigger than 1 and 8 over 15. It's a strict inequality, so we gotta have open, and we're gonna have this situation because a is bigger than 1 and 8 over 15. Okay, so now the interval notation is going to be open 1 and 8 over 15, comma, infinity. Again, infinity side is always going to be open. All right, and then the set builder notation is going to be settable a values, be careful now, such that all the shaded region is going to be bigger than 1 and 8 over 15. So again, this one is the graphical solution set. So this is the graph of the solution set. Now this is called the interval notation. And then this is called the set notation, set builder notation, but I'm just going to write it as set. So that's going to be our answer right here. Okay, so now let's take a look at another one. Alright, so how about something like this? Do not freak out. We're going to do this together. 6h minus 4 times h minus 1 is less than or equal to 7h minus 11. Do not panic. We're going to do this step by step by step. Alright, so first step will be this. Well, you need to simplify the left-hand side and the right-hand side. So what we need to do is we need to distribute the negative 4 to h and then minus 1. So let me just write it. So I'm going to distribute the negative 4 to here, negative 4 to there. Okay, so if I do that, then here what we're going to get is 6h minus 4h, and then you're going to have a minus 4 times minus 1, so you're going to have plus 4 is less than or equal to 7h minus 11. Okay, so now I think we could still simplify the left-hand side of this, so we could combine the like terms. So here what we're going to get is 2h plus 4 is less than or equal to 7h minus 11. All right, now I think we're good to go. So let's bring all the h's on the left-hand side and then all the constants, which is just a numerical value, on the right-hand side. So I'm going to subtract 7h. All right, then what do we get here? We're going to have negative 5h plus 4 is less than or equal to negative 11. All right, next step, you need to get rid of that 4, so I'm going to subtract 4. And if I do that, we're going to have negative 5h is going to be less than or equal to negative 15. Notice that I did not divide it by negative 4 here. I just subtracted both sides by 4. But now let's take a look. In order for us to solve for h, do you see that I'm going to have to divide it by a negative quantity? So if I divide it by negative 5, dividing by negative 5, what's going to happen is that your inequality is going to switch on the next step. So here what we're going to get is h is going to be greater or equal to negative 15 over negative 5 is positive 3. So I'm just going to box that. Now let's get to work. So the graphical solution set, let me just draw the graph over here. So I'm going to bring this over here now. All right, jot down 3. So now this is no longer an x-axis. This is called the h-axis now. Okay, but anyways, let me jot down negative infinity, positive infinity, and all the h values are greater or equal to 3. So here I'm going to have to put a close bracket, and h is going to be greater or equal to 3, so we're going to be shading the right-hand side. All right, so now let's go with the interval notation. The interval notation is going to be close bracket 3 to positive infinity, open. And the set builder notation is going to be settable h values such that h is greater or equal to 3. And that's our answer. So let me just try to box it like this. All right, so let's just get crazy and try this problem now. Okay, so we got too many things going on here, but we got this. Be confident. All right, so first you need to simplify left and right hand side, both sides. So what would I do is I'm just going to distribute the 3 to each, and then 19 to both x and then minus 2. So let's do this. So we have 12x, and then 3 times 4x is plus 12x, and then minus 3 is less than or equal to 19x, and then minus, what is that, 38, and then plus 5x. All right, now let's simplify a little bit more. I could combine these two because they're like terms. So here what we're going to get is 24x minus 3 is less than or equal to, now I could combine 19x and then 5x, so that's going to give us 24x minus 38. Okay, so let's do the same thing as what we did before. We're going to bring all the x's on the left hand side and all the constant term on the right hand side. So how to do it is this, minus 24x minus 24x. Uh-oh, do you see something funky is about to happen? Because look, if I add this, 24x minus 24x is 0. So this is going to give us 0. Minus 3 is less than or equal to 0 minus 38. So that means what? Negative 3 is less than or equal to negative 38. So you're probably sitting there wondering, oh my gosh, what happened to my x? X disappeared. All right, now if the x disappears, your answer is going to be either all real numbers or no solutions. So what determines that is is this a true statement or is this a false statement? If it's a false statement, implies that our answer is going to be no solutions. And then if this is going to give us the true statement, our answer is going to be all real numbers. I will explain why in a minute. Alright, so in this case, what do you think? Is -3 less than or equal to -38? I don't think so, because look, if I draw the number line, and suppose this is 0, -3 will be here, and -38 will be here. So in this case, more left you are, smaller you are. Remember that? So in this case, -38 is less than -3. So this is going to give us the false statement. This is a false statement. So our answer is going to be, so therefore our answer is no solution. Or if you want to get fancy and write the notation, we write it as circle with slash in it. That's same thing as no solutions, or curly bracket with nothing in it is also a notation for no solutions. So let me just box this. And let me just try to explain. Alright, so no solution means this. It's telling you that no matter what value of x value that you're going to plug it into the original inequalities, there is no way in heck that that statement is going to be a true statement. So for instance, okay, so what's the cute number that we can play with? X equals to 0. Again, you can plug it in any number that you want. You can plug it in fraction, negative numbers, positive numbers. But anyway, so when x is 0, let me try to compute the inequality. So what I'm doing is I'm going to bring it over here. In place of x, I'm going to replace it with 0. So you got 12 times 0 plus 3 times, well, 4 times 0 is 0 minus 1. Question is it less than or equal to 19, and then 0 minus 2, and then plus 5 times 0 is 0. Alright, so now let's just simplify this. 12 times 0 is 0, so I'm not going to write that. Now here you're going to have -3. Is it going to be less than or equal to -38? Is that a true statement? No. Okay, so look, left hand side and a right hand side, it doesn't make sense. So when I plugged it in 0, it does not make it into a true statement. Okay, so now let's plug it in like maybe x equals to 1 or something like that. Again, you can plug it in any number and your inequality is not going to satisfy. So here, 12 times 1 minus 1 less than or equal to, is it going to be less than or equal to 19? 1 minus 2 plus 5 times 1. So let's see if this inequality is true or not. Okay, so here you're going to have 12 plus, okay, so you're going to have 3 times 4 minus 1 is 3. Is it going to be less than or equal to 1 minus 2 is -1. You're going to have -19 plus 5. So let's compute. So you got 12 plus 9, which is 21. Is that number less than -14? Oh no, it's not. So you see that, I'm going to put no. So this is just, I'm just only taking two examples, maybe x equals to 0 and x equals to 1. But if you plug it in x equals to -10 or something like that, no matter what value of x that you're going to plug it in, that statement is not going to become a true statement. So since there are no x's that's going to satisfy this inequality, we say that there is no solution to this inequality. But anyways, please let me know if you have any questions about this. Oh, and is there going to be a graphical solution set notation, interval notation, set notation? There is no way in heck that you're going to able to graph a no solutions on a number line. And the set notation will be the curly bracket with nothing in it. and there is no interval notation as well. So if you get no solutions, all you have to do is just write down no solutions and that's it. Okay, let's just do one more example because I feel like I did not do too many examples with fractions involved in it. So let's take a look at negative 21 over 8 times y is less than or equal to negative 15 over 28. Alright, now there are multiple ways that you can do this, but if you want to do this in one shot, trick is this. Multiply both sides by the reciprocal of negative 21 over 8. So who's the reciprocal of negative 21 over 8? That's negative 8 over 21. So what I'm going to do is, let me just first copy and paste the problem. Alright, now I'm going to multiply this whole thing by negative 8 over 21. Do you see why that's going to happen? Because if I multiply these two, do you see that you're just going to get a positive 1? So you have a positive 1 times y, which will just give you a y. But anyway, so let me just do the same thing here. Alright, so what do we got so far? We have y is less than or equal to, now we got a negative times the negative, so that's going to be a positive number. So I'm just going to drop the sign now. So it's going to be 15 over 28, multiplying here by 8 over 21. Now, I don't like to deal with big numbers because I know that I'm going to have to reduce the fractions all the way. Let's see, do we have any common factors here? So let's look at 15 versus 21. I think 3 will go into both. So 15 divided by 3 is 5. 21 divided by 3 is 7. Okay, all right, now let's look at 8 and 28. What goes in? 4. So 8 divided by 4 is 2, and 28 divided by 4 will give us 7. All right, so we got y is less than or equal to 5 over 7 times 2 over 7. You don't have to show me all this step. I'm trying to do is, everything by step by step by step. Okay, so in case you forgot your algebra a little bit. So here, what do we get now? Y is less than or equal to 10 over 5 times 2 is 10. 7 times 7 is 49. All right, so it looks like y is going to be less than or equal to 10 over 49. Now, to write this in a graphical notation, jot down 10 over 49. All right, so y is less than or equal to. Since we have an equal to, you're going to have a close bracket, but y is going to be less than or equal to 10 over 49. So we're going to be shading which side? Left. All right, so here's the graphical notation. Interval notation is going to be negative infinity to 10 over 49, close bracket. And the set builder notation is going to be set of all. Now, what was the variable? The variable was y, so you're going to have set of all y values such that y is less than or equal to 10 over 49. And here we go. How you guys doing up to here? I hope that you guys are doing okay. If you have any questions at all, you know where to reach me. And great job on this section, everyone. I'll talk to you soon.